Hello, Vadym. Yeah, it's cool that we have our next speaker ready. So how are you? How are you feeling?
Everything's right. Thanks for the invite. Looking forward.
Thank you also. So please tell me something about you for our peoples, for our watchers.
So maybe I can also introduce myself during the talk. But basically, I was born and grew up in Ukraine and graduated there in Kiev in KPI, IPSA. Maybe I don't know is that the same name now after more than 20 years. But I'm living since the beginning of the century in Germany. But always happy to support my country. Probably see this my favorite T-shirt, Colors of Freedom from Alexander Usyk collection. So yeah, I started to develop Java in the end of the last century. Basically, now I have mixture of topics, basically AWS cloud, and now looking for the ways and collaborating with the AWS community just to improve the current situation, especially in the serverless space. And this is what my talk is about.
Yeah. Cool. Yeah, I see you have such a great topic. Maybe I would say a hot one, serverless architecture, especially in optimizing performance on AWS. So if you are ready, just not waste your time. Good luck and go ahead, Vadym.
Thanks. So let's first check if the screen sharing works. That's the most important. Can you see my screen and how I'm switching the slides?
Yes.
Okay, then I'm ready. So yeah, thanks once again. The topic of my talk is high performance serverless Java on AWS. I basically introduced myself. Yeah, I have these two passions, Java and serverless. I'm one of the founders, co-organizers of Java User Group Bonn, where I basically live, and I'm also AWS community builders now in the 5th year, mostly dealing with serverless and how to adopt Java there. So you can contact me. I'm quite active on different social medias, posting a lot also about this topic. I could try to do this talk also in Ukraine, obviously, but I think it will be a bit easier for me to talk English, and I hope we can do the talk next time also offline. Yeah, and I would gladly visit Ukraine once again. So yeah, basically nothing to tell about the company. Yeah, I started as a Java developer end of the last century, and now within my company, IP Labs and Bonn, since 18 years, and wrote a lot of Java code. But in the last years, we migrated to AWS, and with certain new challenges, trying to do things as serverless as possible. And yeah, there are challenges with Java as a programming language there we will be talking about. But let's start with Java programming language popularity itself. So there are different sources how you can measure it, like how many GitHub accounts are using Java as a programmer language, or repositories, how many job postings. But anyway, it just doesn't matter what source you will pull. Java is in the top 3 programming languages. It's nearly the same. You have Python and also JavaScript and derivatives like TypeScript, Node.js, and Java is also there. But if you look first of all of the life of Java serverless developer on AWS, and it's not the talk about AWS and serverless in general, but only about adoption of Java, so it requires some understanding of the basics. We will see the situation that now you see in the red color. Yeah, Java 21 supported since November 2023 on Lambda, so we can run our kind of managed Java. And AWS brings its own distribution, Amazon Corretto. This is distribution of OpenJDK. They provide some longer support for long-term versions, even for Java 8, for good or bad. But that situation that Java recent LTS Java version was quickly supported. Nearly after 2 months, it's just not always been the case. You see that Java 17 support came 6 months earlier, so we had to leave basically 1.5 years with the Java 11, even if Java 17 when 18 was released. But now Amazon shows that it has priority, but they will only support long-term versions. So the next one will be Java 25. And you see the people behind working for AWS now behind Corretto. Yeah, and they show that they take it seriously. Nobody needs to introduce James Gosling. I think also Alexei Shipelev did a lot in this space, also in the garbage collection. So they try to improve the things and challenges we'll be talking about. There are also German guys like Volker Simonis and Roman Kenke, which I also kind of know personally. So it's an amazing team. There are many more, but it shows that that's a real brain power behind that. So Java is a very fast and mature programming language, and we love it. So this amazing open source community, amazing open source project, Spring Boot, Quarkus, whatever. Yeah, a lot of stuff. Personally, I cannot imagine my life without using a bunch of open source projects. But the serverless adoption of Java, yeah, how many Lambda functions are written in Java, then there is this comparison on the left and on the right side. The first one is from 21, and then the second one is from last year. So you see that Java is still in the third place, but the adoption increased from, I would say, 4% to maybe 11%, and it's just not too much. Yeah, so Python, Node.js were way ahead. Yeah, so there is this frustrating situation that we love Java, and the serverless is a hot topic. It just doesn't matter where you do it, on what cloud provider, on Kubernetes platforms, with Knative. It just doesn't matter. So the question is why Java struggles, especially now pointing into AWS community. And there are still these challenges with the cold start times, kind of latencies for the first execution, and also memory footprint could be a challenge. So basically, of course, it's not AWS conference. I would explain concepts behind the cold start. So Lambda function is a function as a service thing. So basically, one execution environment can only execute one request, and then this request is executed. Then the environment goes back into the warm pool, and then can be reused. So when the cold start happens, is then there are not enough warm execution environments for this. It can happen if you, for example, deploy your Lambda function for the first time. You created the new one with the code and deployed it. Or, for example, you updated the Lambda function, so the environment cannot be reused. We need a new one with the new code. These are the two examples. Of course, there may be 5 warm executions environment there, but you have 6 requests coming in parallel, and you need one more. So this environment needs to be started, and it's kind of bounded to the additional latency. So what's this life cycle is? Yeah, so the life cycle of Java functions. So first of all, your code needs to be downloaded. Yeah, so first of all, you have then your execution environment. Basically, it's Firecracker VM, basically a container orchestration platform, but provided by AWS. It's not Kubernetes, but the concepts might be similar. Yeah? Then the Lambda will start the Java runtime because we have selected Java as a runtime. Then our source code will be loaded. It's generally, if we deploy it, it's on AWS S3 bucket, it should be loaded. And then Java will do kind of initialization stuff. So the class loading kicks in for the stuff that's required. The static initializer block of the handler function is executed. Yeah, all this runtime dependency injection may take place here, just-in-time compilation, all the stuff kicks in. And the first 3 parts that you see on the right side are this cold start. Yeah, and the warm start, it's only the execution of the function itself. So if we have the warm container, we only execute the handler function if we don't have the warm container, and the container needs to be started. So the whole life cycle needs to kick in, and the first 3 steps are cold starts, and only then the function will be executed. What's important to know is also, if you select, you only assign the memory to your Lambda functions. It just doesn't matter what programming language you use, and the CPU cycle will be added proportionally to the memory that you choose. And you can assign up to 10 gigabytes of memory, but for example, you will get the full CPU cycle for 1.8 gigabytes of memory. So it's generally you need less, and then of course you will only take the fraction of CPU cycle. But what is important in the cold start, in the init phase, you will get full CPU access for 10 seconds for free for managed environments like Java. There are Dockers and so on. They are not managed environments, but for managed environments you get it. And there is a potential to optimize. We will look into this. So basically, this cold start happens. So the question, is it relevant, the cold start, how often it happens? It depends on your use case. If it's just some asynchronous application, it happens, but it just doesn't hurt you. But if it's a public-facing application, it's kind of then the call start can matter, because then somebody is waiting for the response, and it may kick in kind of in 1% of the invocation. So there is one more case when then the container will be kind of not there. AWS recycles the warm containers from time to time to patch the operating system and all that stuff. They don't publish how often it is, but my test showed that, or revealed that after 2 hours, even the warm container will anyway be recycled for these patching cases. So the containers come and go, so the cold starts are also quite common and may hurt you depending on the application. So now let's do some measurements. And the first, this is kind of, we have some simple application also at work. And we have this API gateway in front, and we have a bunch of Lambdas to create the product. We are in the photo product business. We create products, adjust products, delete products. And for this use case, we will store it in this serverless NoSQL database, just for the example. This is more or less standard serverless application AWS. So we will give Lambda functions. We will basically test get product by ID to measure the stuff. We will give it 1 GB of memory. Default, for example, for talking to DynamoDB, you need HTTP client. If you don't, there are options for this, but the default one is basically Apache. You don't need to initialize it. It will happen behind the scenes. And this artifact basically is 15 megabytes of size, will be important. And we will use as a starting point default compilation option, where we switch off tiered compilation, which is default, and say we would like to use a client C1 compilation, but stop at level 1. It was kind of the default back then, and a good starting point for the serverless computing. We will experiment with that as well. And the experiment took more or less, I invoked this function for 1 hour, and in that time, I more or less reproduced 100 call starts, so periodically, and approximately 100,000 warm starts. So basically, each 1,000 invocation was basically here call start. And it's important is I will show you first the measurements of the first 100 call starts. So I simply redeployed the code so that the containers, so that the old code gone, and then started to measure. Not that I have something and then after 1 hour I started the measurement. No, that was kind of brand new code. It will also play a big role. So you will see all these images for cold start, this kind of ice, and then for warm start, so that you will see the things. So now let's do the first measurements exactly with that. And I chose Java 21. So you see here in the cold start, it's quite a big cold start, just without any optimizations. You see the values starting from this P9, P50. I think you can look into P90 because it's something that's, what we can pay attention to. So more than 90% of the requests have then 3,270 milliseconds of the cold start time. So it's quite a big, and we know that all the statistics that after 1 second of waiting, the people may drop, so you may lose the business with that kind of cold start. You see that the warm start, so the execution of the function, warm start or the execution time of the function itself is quite quick. So P97 milliseconds is just peanuts. Even P99 is 20 milliseconds, but pay attention to the max value of more than 1.4 seconds. It will also play the role. So the max value is quite big, but generally the warm start with Java, it's a very performant programming language. But it's more or less designed for the long-living applications and not serverless applications where the functions are quick, short-living functions. So what we'll be talking about, general best practices, how to optimize it. I will introduce you to different approaches. I would start say how to optimize it. The first one is AWS own SnapStart solution for Lambda, but we'll be talking about GraalVM native and measure the stuff, and we will have time look also briefly into provision concurrency. So first, the best practices. They are basically belong to the first, this one, how to program more or less clean. So if you can initialize something or need to initialize something once, do it in the static initializer block. Like you initialize here, we need to talk to DynamoDB, but it could be other AWS services. They all need clients for initialization, like SNS, SQS, everything. It's just some client. And of course, if you do it in the Lambda function, it will be initialized during each invocation, which doesn't make any sense. Do it in the static initializer block. You generally have this CPU for 10 seconds for free. So win-win situation. Also, if you initialize the client, there are some parameters that you can emit, like a region. In what region do you deploy your application? AWS can figure it out. Yeah, they know where you deploy, but it can take several milliseconds or several hundred milliseconds. So it takes a bit of time. So if you know and deploy it only in one region, like we do, simply set it explicitly. This optimization is ugly, but we will a lot benefit from it later. It calls priming. Yeah, so you can prime something in the static initializer block, having this advantage of having this one CPU cycle. And what is this? That requires knowledge to do it, and sometimes, depending on the use case, you may not have things to prime. But for example, in DynamoDB client, if we call for the first time, like something we would like to retrieve something from DynamoDB, the HTTP client will be initialized for the first time. It's not only B that will be initialized the connection, and also and pre-warm things. For example, Apache use caching, and it needs time for basic initialization. But also JSON marshaller, which will be, or some other marshaller you can set, another one that is required to basically marshal from JSON to Java, from string, this kind of things also requires time for the initialization, but only once for the life cycle of the function. In case you prime this in static initializer block, what I'm here doing, it you can pack it to the method. I simply get the product by ID 0 from the database in the static initializer block and pre-warm HTTP client and pre-warm JSON marshaller. And I'm not even interested in the result. Yeah, I only pre-warming the things in the static initializer block using the fact that I have more memory here, and it's even for free. It makes the code ugly. I don't like it as well, but if it's about milliseconds, you can consider it. Basically, you will have some method get product by ID, and you call it get product by ID 0, basically in the static initializer block. It's just repetitive code, but it's just one of the techniques, and we will hugely benefit later. But then maybe the case that you don't have something to do, you don't talk to DynamoDB, you do some math in your Lambda function, then you probably don't have something to prime. But for this use case, it's basically clear. So we will now start lots of measurements. I have all them. You will see the article on dev2ware blog about it, or on my GitHub account. The word of caution, you need to remeasure it even for that use case that I give you. I will explain after all concepts why, but also for your use case. I will give you the orientation, what was working for me, and how you can kind of improve cold starts, but also balance the warm starts, but you need to remeasure. So once again, now we knew that we have this priming. I measured this without priming, and now you understand why this max value, the warm start, is such a big one, because during the cold start, if you don't prime, then the first invocation will also take, in the execution of the function will also takes longer, because all this stuff, HTTP client initialization and JSON marshalling, pre-warming happens then during the function execution. So the first execution will then be longer if you don't do priming. If I did priming, then there will have bigger cold start times than lower warm starts. But basically, you need to sum this max value to this more or less cold starts as well. And then now you have something like cold start starting even from, so the execution of the function, cold and warm start together, they are then kind of 5 seconds even and more. So huge cold start time, basically, for the Java function now. And this is kind of in case you have priming, and priming is possible, but you don't do it because you want to have much cleaner code. And then cold start happens, then the warm execution time also takes longer, or may take longer. So this is kind of the thing. You can apply priming, you can't, but in the end, you just need to think what's the overall latency. Yeah, and it's only Lambda function. In case you have API gateway, you have also 50 to 100 millisecond latency on the API gateway. So the overall request latency will be even bigger than only this cold start time. So general best practices, you need to avoid everything like happening on the lifetime, like reflection, runtime, bytecode generation, proxy, dynamic loading. This everything will increase your cold start times, and that's why this dependency injection frameworks, as they were designed in the beginning. Now we have Spring Boot native, but back then they were not good solutions. I first tested a cold start time with Java in Spring back in 2018, and I think I had something between 8 and 10 seconds Yeah, because all this annotation processing, all this stuff, and the people are scared and say, "No, I cannot work with that." But you can. It's not about Spring. I am now preparing the talk how to optimize Spring Boot applications in Lambda, but basic concepts are similar. So now, just this are big cold start. So how to improve them? First of all, I will introduce AWS own solution, SnapStart. SnapStart advertises it not explicitly for Java, but it's currently only available for Java runtimes, like 17.21. And I don't know if there will be other support, but currently it's available since reInvent November, December 2022, and only support for Java is added. So I extensively blogged about this, but also how to use it with this Micronaut workers, Spring Boot applications, now even the Spring Boot 3. So if you follow me, you can find me on Dev2. You will have very detailed explanation of all that stuff, but I would like just to show you the things here. So what's the concept behind SnapStart? It divides the life cycle, or it will be used in two life cycles kind of Lambda function. The first deployment phase, yeah, and then the invocation phase. So what's happening now additionally, and you can enable SnapStart on the per Lambda function basis. So it's up to you to enable it or not. Yeah, but if you enable it, then during the deployment phase, there's several steps are added. So you see here the create snapshot, the last one in the first row. Yeah, we have hooks. We will be talking about these hooks later. But first of all, the snapshot will be created. And in case of the invocation with SnapStart enabled, the first thing is to restore this snapshot. So these are additional things. So now first let's talk about what are those snapshots. Yeah, how it works. So basically, this is the Firecracker microVM snapshot. Yeah, Firecracker, the whole execution environment, the whole microVM snapshot will be taken. In case you're using SnapStart, it will be then encrypted and placed in the tier low latency cache. We'll be talking about at least several words about the cache. And then this the snapshot, it's placed in each availability zone of your region. Yeah, so this is in case one availability zone is down, you can use it. And yeah, these hooks are there. And then, of course, if you then execute, then this is the resume step. This is more or less the snapshot will be more or less then restored or resumed. So first of all, what's the promise? Of course, the promise is that at least restoring the snapshot is much quicker as a cold start. Yeah, otherwise it just doesn't make any sense. Yeah, and we will see if this is true or not. Yeah, can it be better than this 3, 4, 5 seconds of the cold start? That's the promise behind it. But now, of course, you are in the Java world, and you basically for sure heard the terms CRaC, checkpoint restore, and user space, and also CRaC. And I would like just simply to explain the differences and what's AWS doing. So CRaC is basically the technique available on Linux since 12 years, just to move containers around from host to another host. Yeah, and just simply to continue from another host. Of course, it has challenges, open files, network connections, sudden change in the value of system clock. Yeah? So what's the difference? So Firecracker microVM snapshot is not based on CRaC. It has the similar goal, but Firecracker snapshots the whole running OS. And as far as I know, CRaC snapshots or saves a single process. It has trade-offs as everything, advantages of SnapStart or Firecracker VM. SnapStart is that we don't need to care about the file handles anymore. Yeah, that's always the problem. If you have file handles, open file, or open connection, it's not the issue with CRaC, with SnapStart, but it has drawbacks to receive random, def random, and system clock, and so on. So this is kind of the stuff. Both have challenges with time-based caches. It's per nature, it's not recommended to use time-based cache because, for example, you can save the value and say, I would like to save it for 10 hours, but then you start the Lambda invocation, it restores it in the first 8 hours, 9 hours, 59 seconds, you have the value in the cache, but there can be some restore operation after 10 hours and 1 second, and then the value is not there. So it's difficult to rely then on time-based caches, and you simply should avoid it. So then once again, what this happens, you can activate basically SnapStart in the configuration of the Lambda function, which uses Java runtime by simply, it's more or less checkbox. Yeah, and then all this process creation will take place. So this is, if you enable SnapStart, this is what you see during the deployment phase. You see that init start is called. So init start, the initialization phase of Java function, which will only be called in case of SnapStart. In there, this is the pre-warming takes place. This whole static initializer block of the function is invoked, but not the function itself, so not the handler method. And then the snapshot is created. In case you then invoke the function, so real traffic comes and SnapStart is enabled, then you will see here the restore time. Yeah, so the snapshot will be restored. And for this, you see is SnapStart enabled or not. Yeah, so you see restore start, restore report in duration, and all the things. So this is how you see it. So now we also saw these hooks. Yeah, before create snapshot, there is an optional pre-snapshot hook, and in the invocation phase, after restoring the snapshot, there is a post-snapshot hook. So what are those hooks, optional hooks? So Lambda uses CRaC API for those tools, but only the API. It's not the CRaC. It's not related to CRaC. They could also use another API. It's basically two methods. And there is a kind of confusion that it's based on CRaC. There is nothing common, basically only the API. And probably you know CRaC. I shouldn't tell you about this. It's quite a lot of rumors there with Azul people during this. You need special GDK for this. Azul provides and some others, but not an open GDK, which is CRaC enabled more or less, but this is more or less for restoring the GVM. Yeah, saving and restore on the GVM level. So once again, SnapStart only uses the API. The promise is the same. After the restore, it should be kind of the first operation should be quick for CRaC. But this is how you can use the SnapStart with CRaC. And you can use it for priming, once again, to prime something. So you need this dependency or CRaC. You need to implement the resource interface, which gives you this method before checkout and after restore. And in the constructor, you need to register this class. This is the Lambda function, get product by ID as the CRaC resource. That's more or less the same line that you need to copy every time. So for what you can use this, once again, I only use this before checkout, before snapshot is, before checkpoint, before snapshot is taking, I'm doing this priming. I'm calling this product, get product by ID. What's the benefit? The priming will happen in the deployment phase. So there is no real traffic. So during the deployment phase, I pre-warm the things, and they are now will be snapshotted, and then the things are in the snapshot. Yeah, and then the snapshot is restored during the live invocation. Then the things are there. So priming with, especially with CRaC, yeah, if you have something to prime, it has a huge benefit, and we'll be seeing the results. Basically, there is also from AWS guys guide how to use priming effectively for known use cases, like this is for DynamoDB. So there are some known cases currently there. I personally would wish that it will work out of the box without implementing anything. Yeah, so there are some common use cases, and this can be done behind the scenes. But currently, it's not the case. We need repetitive logic. I can also suggest you to watch the talk. There are links below. AWS Lambda under the hood from the developers of like Mike Danilov, and he also extensively talking about SnapStart and caching, how they implemented this, how they improved it. Just for me, I only kind of explain you the concept, but he went much deeper in the KubeCon session last year. So before I show you the measurements, there are some challenges and limitations. Yeah, once again, it only supports Java. The deployment time, in case you enable SnapStart, takes additionally roughly 2.5 minutes for one Lambda function. The reason is take the snapshot and store it on each availability zone in the cache. It takes time. I saw improvement by 30 seconds. Kind of 1 year ago, it started even slowly. So there may be improvement, but the developer experience can be a bit broken. Yeah. Also, the snapshot will be deleted in case your function is not invoked for 40 days for cost reasons for AWS. So you need basically to think to enable it for the hot functions, and it's not very suitable for staging application where you may have some different invocation pattern. And it has also some limitations. Currently, if you use provision concurrency, you know what it is. It's not supported. It only supports x86 architecture, not ARM, which is supported in Lambda and Java as well. It doesn't support that you attach NFS-based system, Amazon Elastic File System. I personally use S3. For me, it's okay, but there are other use cases and all this stuff. So there are some limitations that you need to be aware of. It's not for free, kind of. Yeah, there could be in the next step. So now I showed you the first measurements of cold and warm start, and then now I don't have a pointer. They are now on the left side, yeah, where we did not activate SnapStart. Now you see in the middle, P90s for our use case in case we activate SnapStart but don't do priming. Yeah, simply we are lazy, we don't do priming. So what you see, that's the cold start. Yeah, you see in the left bottom cold. So this, we are talking about cold start. You see, let's look at this yellow one. This is P90. So you see that this from 3.3 seconds, it went down to 2 seconds, basically by only checkbox enabling. Yeah? In case I'm using priming and prime the stuff, you see P90 is basically 1 second. Yeah, and for P50, it's even 500 milliseconds. So it's a huge improvement if you have something to prime. Yeah, and this is the promise of, you see, SnapStart generally produce much better results, even without priming, but with even more with priming. This is the warm start. So the question was, does it change something to have SnapStart? SnapStart is basically for cold starts improvement. So you see for all use cases, there is one interesting thing in this. You see only until P99, all results are similar, but now see the P99.9 and max values and look into the right. This is in case of priming. There are much lower values because we have already primed everything. Yeah, so the warm execution doesn't have these outliers in case we use SnapStart. It's just everything is in the cache. So this is once again, it also improves basically also warm start times in case we did not do priming for if you don't enable SnapStart. So you see huge enablement. So now this, once again, this is our basic application. Now I will be a bit showing you what you can also kind of try out to figure out, will it benefit you? Yeah. So first of all, we can experiment with Lambda memory setting. We can give less memory, more memory. It's also a cost factor memory. Yeah. So the memory duration, to be honest, is a cost factor. So how much memory have we given and how long did the execution take? Sometimes you give more memory and you have then more CPU. Once again, we talked about this, and then the Lambda function is then quicker. Yeah, and then you have basically even less cost. But now let's see, this is the cold start without SnapStart. I just gave between 1/4 of the gigabyte and 2 gigabytes of memory. And basically what I saw for the cold start, 1 gigabyte for this use case, but I also hear this for other people, 1 gigabyte is a very good memory setting for Lambda function. Yeah, so do you see that giving more memory just doesn't improve cold start? Giving less memory make it a bit worse. So the sweet spot for this use case, once again, is 1 gigabyte. This is the warm start. Once again, this is the same picture. This is, first of all, without SnapStart. Yeah, I just measured all 3 use cases here. Yeah, this is the cold start with SnapStart enabled, but without priming. So cold start, once again, the same picture. Somewhere 1 gigabyte is a good sweet spot here. Yeah. Just doesn't make any sense to give more, even with SnapStart enabled without priming. Yeah, these are once again the warm starts with SnapStart without priming. Basically the same situation, somewhere around 1 gigabyte is a sweet spot. This one becomes interesting. This is cold start, SnapStart with priming. You see that the values are quite close for 1 gigabyte, but also for 768 megabytes. So using the priming, you may be thinking about giving a bit less memory. So look into this, maybe 668 will be enough. And you will have basically the warm start is also similar for this. So giving less memory, having the same warm start and cold start will save you money on this. So SnapStart with priming is a really powerful technique. So let's do some more things. Like let's look into deployment artifact size. Sometimes it's just, I have only basic application. You can have much more dependencies and the application might be bigger than 15 megabytes. So basically, it's a known fact that the bigger the size of the artifact without SnapStart, forget the SnapStart, for each programming language, the bigger the cold start is, because this package needs to be downloaded. In the cold start phase, bigger package, more initialization work. What I wanted to figure out how it behaves if we have SnapStart, if it's only restore of the snapshot, does the size matters here, and how it relates to the priming also. So you see 3 use cases: small hello world application, nobody writes it, but it's only 137 kilobytes for me. Our application was 15 megabytes, and I wrote some bigger one, more dependencies, 50 megabytes. And it's still true if you see in the middle and the right one that the size matters here also. So this is only P90, but you see that basically the bigger the package is, then the bigger the cold starts are. Also with SnapStart and also with SnapStarted priming. So it's, once again, it comes down package only what you use. And you can add much more AWS dependencies that you need. Also exclude with the scope test or JUnit and all this stuff. The more you package, the bigger the cold starts will be. Having Tomcat with more dependencies, it just doesn't matter. Maybe it's about milliseconds, several 100 milliseconds more start, and then the Tomcat runs for hours. We are talking about short-lived applications. It will impact you. So look into your dependencies and strip away everything that you don't need. So there are other ways how you can package applications. For example, nearly all Lambda functions have the same dependency that we always kind of bundle. In our case, I just always bundle Java core, Java events, in our case, logging or Jackson, Marshall. And it also increases all the Lambda packages. I have multiple Lambdas for different projects, and they have the same dependencies. So this deployment phase taking longer, and this also all that stuff just to download the code. The AWS provides you Lambda layers for all programming languages that you can push the layer with some dependencies that you would like to reuse. And then if you write the Lambda function, you see it on the right side, you can use the Lambda layer. So your package doesn't need to contain with Lambda function the dependencies anymore, but you simply more or less then reference the layer. I wanted to figure out if they're using Lambda layer, at least these 5 dependencies, what does it bring? And currently these are very, very fresh measurements from the last week, where you see the red one, I'm push all dependencies within the POM XML, so there are no layers, and the green one, we have layer, and I currently have the results. It's only P90. For other Ps, it's just the same, but we see that the Lambda layers produce bigger cold start time. And this is the warm start time for this, and this is basically we have here different stuff here, but basically you see. So I personally see that the layers currently contribute more to the cold start. But here's the warm start. You see the results that the green one with Lambda layer is kind of better, but if you see they are all between 7 and 8 milliseconds for P90. So it just doesn't matter, basically. It's 1 millisecond, but you see here that the difference for the cold start time is about 300-400 milliseconds. So basically the warm start just doesn't matter, but for the cold start, the Lambda layers produced a bit more, a bit bigger cold start time. So also experimented with Java compilation. You're all Java developers, you know how the things work. You know that there is C1, C2, default is tiered compilation. And once again, the best practice before SnapStart enabled was to disable tiered compilation and use tiered stop level 1. This produced the better results. That was tested, just that it's enough. You don't need this fully profiling stuff. It's just taking threads and also computation from your Lambda function, and then Lambda function the container will be more or less released quickly, so you cannot benefit from this. The same is true for C2. Doesn't make any sense because it may kick in after 10,000 invocation of the method, and you don't have so many invocations. So you're doing all that stuff for nothing. So that was the idea that produced the better results. But I wanted to test how it behaved with SnapStart and SnapStart priming. So what is the compilation option produces the better results? So you see here the graph only P90. The same will be also for others. You see the red one is tiered, is default, and the green one hell green kind of, this is stop at level 1. There is stop at level 2, stop at level 3, and stop at level 4 is basically C2. So more or less what I see that I have for cold start the better results for tiered compilation and stop at level 1. They are very, very close, and you see kind of C2 produces, and also all the stop level 2, 3, 4, they produce the worst results for cold start time. Yeah, with priming, it's basically balanced, but at least if you don't use priming and have SnapStart enabled or not, you see C2 compilation is the worst one. So I would recommend you to look into tiered and stop at level 1. This is then the warm starts. It's vice versa. So the stop at level 1 was, I think, better for cold start, and here it's kind of balance act. Yeah, you can choose either one or another, and then look into the balance of cold and warm start time. So this is basically my advice. You can also go with the default tiered compilation. There's nothing wrong, especially with SnapStart. You will have good results, but just don't use C2 stop at level 4. So there are other dimensions. The usage of HTTP client. I have little time, but I will speed up. Yeah, default one is Apache. If you don't do anything, you can set others. Like there are 2 others, URL connection that you can set, and AWS provides its own AWS CRT client, which is for short-living functions, because Apache HTTP client, it takes time for serialization, it uses heavily caches, all that stuff that you don't need necessarily for short-living functions. I did some tests. Of course, you then need to include dependency. If you don't use Apache as a default, then you will need to include the dependency by yourself. And basically what I found out, these are the cold start times, also once again P90, and what you see AWS special Apache client produces the best results for SnapStart without priming and with priming. With priming, you see that all results are balanced, so they're more or less equal. But especially if you don't use priming and all that stuff, then AWS own innovation kind of CRT client, they use native code, C code, so that's very performant one. Yeah, the warm starts are also kind of comparable for all 3. So for cold starts, I will recommend that. I will not go into the asynchronous clients. You can do asynchronous communication as well. It's just another topic. Would you like to be synchronous, asynchronous? But basically, of course, AWS also have kind of this decision tree, what client to use, because I only use the default configuration. I did not use I didn't set any other parameters like timeouts and all that stuff. So you need to experiment with for your use case if you don't use default values, whether it's true or not. So once again, that's one last important topic, this load level tiered cache that is used. I showed you all the measurements with AWS SnapStart. I showed you the first 100 cold starts if you enable SnapStart. But the thing is, with each subsequent invocation, with SnapStart enabled, they become quicker due to the cache. So if you have the first invocation, new Lambda function, the cache is empty. And then the cache will be filled in chunks. This is a tiered cache, like Docker images in layers, similar things. And this is what I would like to show you. In case you enable SnapStart using priming or not, I just simply also show you the values of the last 50 invocation from this 100. Basically, yeah, the invocation number from 51 to 100. And you see that the results are really getting better. Yeah, was what I saw, that after 50 invocations, more or less, I have stable, quicker results. So once again, if you measure something with SnapStart, just don't give up after several invocations. The first 50 are slower, but after them, they are quicker, even tested than the next day. So there's some, I don't know exactly how this caching behavior works, but I have really good results also on the day after this without redeploying Lambda function and all that stuff. So basically, you need also to look not only the first X invocations, but also see how it develops. And once again, after the 50 invocations, you have stable, much better results. And they are just, yeah, even the second invocation is also with the cold start is quicker than the first one, but the top performance starts somewhere currently up from 50. So this is once again the thing that you need to look. And so after the 50 invocations, you have even P90 of 700 milliseconds with SnapStart and priming. Very, very competitive. So GraalVM, only briefly, everybody knows what it is. There are speakers from Oracle. Olga, I saw, Alina is talking a lot. It's basically, you know what is ahead of time compilation. And the ahead of time compilation is, of course, a huge benefit for serverless architectures. And of course, having native executable is just good for performance and all that stuff and cold start times. This thing is AWS doesn't offer managed GraalVM. So the question is how I can experiment with GraalVM. AWS provides the option of custom runtime. You see here this one, custom runtime, so you can bring custom runtime. What is this? Is basically zip package with a bootstrap file there. And bootstrap file, in case you would like to use GraalVM native image, is basically your native image. The thing is, AWS custom runtime only supports Linux executables. So it should be Linux native image, even if GraalVM supports others. And yeah, it's now release calendar changed. We have also each version, for each version, there is a GraalVM version. Previously, it was LTS, as far as I know. Also, community edition is Oracle is also contributing there. And yeah. Really cool stuff. I wanted now to show you, I did the same application and measured the cold start with GraalVM. And you see on the right side, GraalVM native image comparable to SnapStart, it produces better results. Without any doubt, 500 milliseconds more or less, you see all P's with max are very close. But once again, we will have better result with SnapStart after 50 invocation as well. But nevertheless, GraalVM produces better cold start times. And it also produces, you see here, better warm start times. Yeah, warm starts is not a big problem. Java is compatible here, competitive, but anyway, you need to know this. Yeah, this is the max values of GraalVM, and you see on the right side, this is P99 and max values of the warm start time, also superior values. Yeah, you don't have these outliers, and even much less outliers as with SnapStart and priming. So without any doubt, big thing. And also what I did, I measured GraalVM with different memory settings. Yeah, I took from 1/4 gigabyte also to 1.5 gigabytes. And you see that basically you don't need to give, this is the cold starts, 1 gigabyte of memory. It's okay to give 768 results. In my case, is comparable. And even with 1/2 gigabyte, it's not a big difference. Yeah, and you save money. And the same is for the warm start time. Yeah, yeah, you can go below 1 gigabyte, which will also save you money. And it's, of course, another benefit of the GraalVM. Without any doubt, these are also max values for warm start time. Yeah, so you see that you don't need too much memory, basically the same statement. But yeah, GraalVM, powerful, nothing to say. But of course, once again, it requires native on Linux executables, and it also pushes the pressure on your CI/CD. Yeah, for me, I needed to give 6 until 10 gigabytes of memory just to build GraalVM native image. It also took for this use case 2.5 minutes, compatible with deployment time of SnapStart. Yeah, but you need sometimes just to scale CI/CD. If you are building too many Lambda functions in parallel, all these GraalVM native images, you need to pay for CI/CD. So once again, yeah, it's an up to you. And the small cost negative factor is it's just custom runtime. So this initialization phase is not for free for 10 seconds. It's only for managed Java 21. So basically, this is the situation. Yeah, that's a trade-off. CI/CD scaling, it's also a cost factor. You can use managed solution, it will be scaled for you, but it's a cost factor. And of course, you need to pay attention to reflection because, for example, the invocation of the Java function requires reflection. You define your Lambda function infrastructure as code. All entity objects, like in my case, product, and some others that API gateway uses, they need to be extra declared in the JSON file because they will be instantiated via reflection. Yeah, so it's a bit more work, and depending on the complexity, even Yoda time needs to be put there. It's used by API gateway to transform string to date. So you need this. If you did it once, you know what to do, but basically you can have this life effects. Yeah, you need to pay attention to put everything together, not to run into problem in runtime. But for this, you can use this frameworks and library page on GraalVM. The major frameworks are beta tested to be GraalVM compatible. Micronaut, Quarkus, Spring, Helidon, and you have also the list of the packages of open source projects that are also tested, and they don't have this reflections and all that stuff that can impact you on the lifetime. But of course, you can go one version up, and then maybe it's then have problems. So you need to pay attention. It's just a trade-off. So I'm basically done with that. Before I come to some conclusions, I showed you DynamoDB. Not everybody likes NoSQL databases. AWS provides you managed databases also for relational databases for serverless use case. It's called Aurora Serverless, and it provides you data API that you can talk to this database via HTTP like DynamoDB. It has advantages not to manage your connection pool, which is the short-lived Lambda functions that can be too many. It can be a problem. It's not worth doing. There are other solutions, FDS proxy, but data API provides you the easiest solution just to talk via data API. I also measured the things and blog about this, and this is my new blog in just part 7, how to run Spring Boot applications on AWS Lambda. There are so many beautiful projects like serverless container from AWS, AWS Web Adapter, Spring Cloud Functions. Of course, there will be also measuring Docker and GraalVM native image. So it's another topic. I will be talking about this and will apply with the talks, but I didn't use Spring for this application, for this demonstration. So once again, now we know the concepts, why you should remeasure it for yourself. I measured the things for Java 21 starting from end of November last year, and every measurement used some managed minor version of Java 21. It now, AWS changes this all the time. They just used a bigger number of minor version, kind of the recent one that they have, and it can contain improvements. So the Java JVM can contain improvements to the cold and warm start time, so remeasure it. Lambda SnapStart, snapshot, create and restore may have improvements if you will test today. The snapshot creation phase can be quicker. Snapshot restore phase can be quicker. Firecracker VM can have improvements. GraalVM, I used 21 for these measurements. There is now 22 that you can use, and all the stats. There are also still servers behind Lambda, and you have Java memory impact, L caches, RAM, cache hits, cache misses. So there can be some differences if you will even retest what I published on GitHub. So basically, there is also Project Laden, currently bringing all these capabilities that Java will be more suitable for the serverless world and to the JVM itself, because GraalVM is a separate thing, may take years. Basically, that's my feeling, but it's interesting to see that Java is evolving there. So this is basically what I wanted to tell you. If you would like to ask me what to use, AWS SnapStart or GraalVM native image, I personally say I like managed solution. And SnapStart is checkbox. I don't need to think about this snapshots and restore and all this CI/CD of this. So if I'm willing to take 700 milliseconds more of the cold start, and it's not so business critical to have 700 milliseconds instead of 500 milliseconds, I will go for SnapStart. If you would like to just squeeze every possible milliseconds in the cold and warm start phase, then go for GraalVM. It's an amazing technology. This is basically my advice to you, but measure for your use case and then decide. And that's basically it. I hope I done it in time and no speaker will be waiting. And I can think just to stop sharing the screen, and there will be maybe questions.
Thank you, Vadym. You did great. Very interesting topic. I could say useful topic. So now it's time for question. We have, I see, 2 questions from our live chat. The first question from Mr. 7. Looks very famous title. But let's see the question from Mr. 7. So let me use my phone or cool.
I can read it. Can the use of GraalVM or other OT compilation techniques reduce cold start time for Java? Maybe the question was asked before I was talking about it. If I look into the time, because I spoke then about GraalVM, yes, of course. So maybe you were a bit not patient, too much talked about SnapStart in the beginning. I could do it vice versa. But of course, I showed you the metrics. And yes, another question, is it possible to use SnapStart in conjunction with provision concurrency? This was also on my slide. Is one of the limitations of SnapStart. You cannot use provision concurrency with there. Yeah, so if you would like to perform with provision concurrency and you know the time frame where you need more, then it's the use case for provision concurrency. Then no, you cannot use SnapStarts, but basically then you have the containers anywhere pre-warmed, and SnapStart is for the cold starts. But that's why it probably will never come.
Yeah, thank you, Vadym, for your answers. And also, we have one question directly from our hosting room. Oleg, please go ahead with your question.
Hi, Vadym. Thank you for your presentation. Pretty good deep dive into the various techniques, how to improve startup time and what to avoid. Yeah, great. Pretty insightful. And I have one question. How do you see future of Java serverless evolving in next few years? So despite this improvements that we already have, like GraalVM, SnapStart, now Project CRaC, maybe something extra new might be in the future, or how do you see that? Thank you.
So I can only tell about AWS. So basically, I think other cloud providers are doing this, at least research in the same space. So I think, of course, because these improvements, now, I mean, it took time also for GraalVM native image to become more mature, the same as SnapStart came 1.5 years ago. Of course, many developers were hesitant to migrate. Yeah, and especially it's important that you can migrate with less effort as possible. If you use Spring Boot, just try to migrate it and reuse the code as much as possible. So I think we are there now. Yeah, so there's a quite competitive cold start times. It's not about each 100 milliseconds. Then if you are reached a certain level, I personally will. My first thought was the AWS will release managed GraalVM runtime. I thought they will be working towards this 2 years ago, but they did their own stuff with SnapStart, and I think they will be investing in this. And they will try to reduce the cache creation and restore time. And if it's still 600 milliseconds for restore time, maybe you can improve it. Yeah, you will squeeze another one, but basically you can reuse. Micronode has CRaC API for SnapStart. Quarkus the same. So basically, Spring native, you can use now the stuff. That's the basic thing. Yeah, of course not classic Spring, but Spring native stuff and all the stuff. So also Spring with SnapStart is working beautifully. I think that the people are a bit hesitant because they missed all those improvements, and they measured this 6 years ago and say no way. With 10 seconds of cold start. I can totally understand this. But there is a room of improvement. I personally, it should be more mature. I hope I answered Oleg.
Yeah, sure. Thanks a lot. Thank you.
Yeah, thank you, Vadym, for being with us. Ukrainian is everywhere. So looking forward to you for our events next years. And we'll be in touch. Thank you.
Thank you. Thanks for the invite.